Alright, welcome back. Here are our first notes for Chapter 10.1, Naming Polygons. Chapter 10 is all about polygons and areas. Start off with naming some polygons here. Three-sided polygon, we should all know that one. That is a triangle. And the prefix there is tri, meaning three. Four-sided polygon is called a quadrilateral. Prefix there is a quad, four sides. Five-sided polygon is a pentagon, and penta is the prefix. Six-sided polygon is a hexagon, and the prefix there is hex. Seven-sided figure is called heptagon. The prefix there is hept. Eight-sided figure is called an octagon. That's our prefix is oct. Move up a little bit. Nine-sided figure is called a nonagon. And our prefix there is non. Last one we have right now is a decagon. 10-sided figure, and that prefix is deca. Okay, that doesn't look very much better. That must be a spot there. I'll move this up. That's better. And the last one, it's a polygon with n number of sides. We call it an n-gon. So those 3 through 10 sided polygons have special names. The rest of them are called n-gons. Okay, moving down into our figure right here, we've got a polygon with 1, 2, 3, 4, 5, 6 sides. So we have a hexagon here. I'm going to put some names to those points. Point P here is called a vertex, just like in all of our other figures, and that's a point. Okay. PT, that dotted line here, that dashed line, is called a diagonal. Vertex Q and R are called consecutive vertices. And you would name them Q and R. And then I've got ST here. ST, oh, that's a very large, sorry about that. We don't need it that. We've got ST and RS. Those are our consecutive sides. Fix that. All right. Moving down to the next box here. Got some special names for some polygons here. An equilateral polygon is a polygon with all sides congruent. I'll draw a pentagon here. It's a five-sided figure, and to show that those are all congruent, I would have to give the tick marks for each of the sides, noting that those are congruent. An equiangular polygon is a polygon with all angles congruent. Give you another pentagon here, and this time all the angles would be marked congruent. All right. A regular polygon is a polygon, and that keyword there is regular. So regular polygon here. is a polygon with all sides and angles congruent. Alright, I'm going to draw a square for this one, mark that up so my sides are all congruent, and then give you the right angles to show my angles are congruent. Alright, a convex polygon is when all of the diagonals are on the inside of a polygon. So if I were to draw the diagonals here, they all are on the inside of that polygon, the interior of that polygon. Okay? And a concave polygon is one with when at least one diagonal lies outside the polygon. So I'll draw that, and then the diagonal would go from there to there. Diagonals just connect two different vertices. Alright? And let's move to the next. Alright, so we're going to identify the polygon that we're given here by its sides. So identifying it by its sides is that first box at the top. I'm just going to count them. So we've got 1, 2, 3, 4, 5, 6, 7, 8 sides. So when we have 8 sides, we have an octagon here. Alright, so octagon. Determine whether it appears to be regular or not. And I'm going to kind of look, it appears that AH, since we don't have any markings, we're going to go with appearing, but it appears that this side AH is actually a little shorter than that side HG. So in order to be regular, again, just a reminder, all sides have to be congruent and all angles have to be congruent. So this is not regular. I'm going to say that AH is not equal to HG. It appears smaller. Okay, again, they have to be the same. Name 2 pairs of consecutive vertices. So vertices are those angles. So I'm going to pick B and C. So B and C are consecutive vertices. Maybe I'll pick E and F as well. Notice I'm not naming them with an angles, they're just points. And then name 2 pairs of consecutive sides. I'll go ahead and pick AH and HG. And then I'm going to go ahead and pick CD and let's do DE. Again, consecutive means right next to each other. Okay? Alright. Example down here, find the perimeter of a regular octagon. First thing I want to make sure we know is that an octagon has 8 sides. So if a regular polygon, notice that word regular there, means that all of my sides are the same. So I've got 8 sides and they all measure 7.6 meters each. My perimeter is going to be 8 times 7, which is 60.8 meters. Alright, now last example here, perimeter of a decagon. So a decagon has 10 sides, and again, it's regular, so I know that the perimeter is going to be equal to 10 sides times that 12 feet. So I know that the perimeter is 120 feet. Alright, that's your notes for this first section here. Here's your assignment down here. It's assignment number 1 right here in the packet.